This resource is the third in a multi-part series that considers a number of topics in trigonometry. Part 1 looks at radians, defining this alternate method for measuring angles, and providing methods for converting back and forth between degrees and radians. Part 2 focuses on right triangle trigonometry, looking at the 6 trigonometric ratios. It also looks at the identities that define the other ratios in terms of sine and cosine. Part 3 explores the connections between trigonometry and the Cartesian plane. Part 4 considers the inverse trigonometric functions, which are used for finding angles when the ratios are known. Since we want to find the connection between the trigonometric ratios and the Cartesian planes, we need to see the general setup. We start with some point x, y, which we connect to the origin. This segment is our hypotenuse. The length of the hypotenuse, which we will call d, is the distance between the point and the origin. We also draw in the line straight down from the point to the x-axis. The sides of the triangle formed have lengths equal to the x value and the y value. The angle we consider is the angle between the x-axis and the hypotenuse. With these definitions, the y value is the length of the opposite side. The x value is the length of the adjacent side, and d is the length of the hypotenuse. Now we can find our trigonometric ratios. The sine is the opposite over the hypotenuse, so we have the y value over d. Cosine is adjacent over hypotenuse, or the x value over d. Tangent is opposite over adjacent, or the y value over the x value. Let's look at an example. Suppose we have the point 9, 40. We want to find the trigonometric ratios for theta, the angle formed between the x-axis and the segment containing the origin and the point. First, we need to find the distance, which is the length of the hypotenuse. Since we have the lengths for two of the sides of our right triangle, we can use the Pythagorean theorem. Plugging in our values, we have 9 squared plus 40 squared equals d squared. Squaring our numbers, we have 81 plus 1600 equal to d squared. Combining leaves us with 1681 equal to d squared. We take the square root and find that our distance is 41. Now we can find our ratios. The sine of theta, y over d, is 40 over 41. The cosine of theta, x over d, is 9 over 41. The tangent of theta, y over x, is 40 over 9. But what happens if our point is not in the first quadrant? Is it possible for our functions to be negative? When considering sine and cosine, remember that the length of the hypotenuse is a distance. Distances are always positive. Whether the sine or cosine is positive or negative depends on whether the x value or y value of the point is positive or negative. We also need to remember that tangent can be thought of as sine over cosine. If the sine and cosine have the same signs, the tangent will be positive. If the signs are different, tangent is negative. In quadrant 1, the x values are positive, so cosine is positive. The y values are also positive, so sine is also positive. Because both sine and cosine are positive, tangent will also be positive. In quadrant 2, the x values are negative, so cosine is negative. The y values are positive, so sine is positive. Because sine is positive and cosine is negative, tangent is negative. In quadrant 3, the x values are negative, so cosine is negative. The y values are also negative, so sine is negative. Because sine and cosine are both negative, tangent will be positive. In quadrant 4, the x values are positive, so cosine is positive. The y values are negative, so sine is negative. Because sine is negative and cosine is positive, tangent is negative. The previous slide had lots of information, so let's summarize. In all quadrants, at least one function will be positive. In quadrant 1, all the functions are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. In quadrant 4, only cosine is positive. An easy way to remember which functions are positive in each quadrant is the mnemonic, all students take classes. Let's take a look at an example that uses this concept. Suppose we know that theta is an angle terminating in the fourth quadrant, and that cosine of theta equals 11 over 61. We want to find the values for sine of theta and tangent of theta. First, we have to find the missing side of the triangle, which is the y value of the point. We do so using the Pythagorean theorem, except we know the value for the hypotenuse. Plug in, square, subtract, and take the square root to find y equals 60. Or does it? We need to remember that we are in the fourth quadrant. Therefore, the y value must be negative. Our real y value is negative 60. The sine of theta is the y value over the hypotenuse. So we have negative 60 over 61. The tangent of theta is the y value over the x value, or negative 60 over 11.